Hello students, here we will discuss about non-homogeneous partial differential equation with an example. Consider non-homogeneous partial differential equation. So it is a non-homogeneous partial differential equation operator form. Earlier we will learn about a homogeneous partial differential equation. So here the expression f of dd dash is not homogeneous. Suppose it is not homogeneous, then it is called non-homogeneous. So for example, if we take this equation, so here the partial derivatives of having order 2, order 2, order 1. So order is not same, so it is known as non-homogeneous. Now we can solve this non-homogeneous partial differential equation as usual by taking z equal to cf plus pi. So what is the cf here? Complementary function, and pi here particular integral. So to find complementary function, just we have to take the right hand side as 0, and now we have to compute complementary function in two cases. So in first case, suppose f of dd dash can be expressed or resolved into non-repeated linear factors. So look like this: d minus m1 into d dash alpha minus alpha, d minus m2 d dash minus alpha 2, and so on of z equal to 0. Then we can write the complementary function as cf equal to e power alpha 1x phi 1 of y plus m1x plus e power alpha 2x plus phi 2 of y plus m2x plus and so on plus e power alpha nx phi n of y plus mnx. So just we have to remember this complementary function whenever the expression f of dd dash can be resolved into non-repeated linear factor. So for example, so here the given equation is solve the partial differential equation. So clearly it is not a homogeneous, so hence it is known as non-homogeneous. Now to find complementary function, now this can be, the expression can be written as d minus 1 into d minus d dash plus 1. So it is split by using the synthetic division method or Horner's method. Now comparing this with d minus m1 d dash minus alpha 1, d minus m2 d dash minus alpha 2 of z equal to 0. So comparing with this, we will get m1 and alpha 1 value, m2 and alpha 2 value. So substituting these values in the complementary function formula, so we will get the required complementary function. And particular integral, which is as usual, the particular integral is 1 by f of dd dash sine of x plus 2y, that is right hand side of the equation. So here we have to put d square equal to minus 1 and dd dash equal to minus 2 and d dash square equal to minus 4, but here the expression does not having d dash square. Suppose there is a d dash square, then replace with d dash square equal to minus 4. So just we have to replace these values 1 by d dash. So on simplifying we will get minus 1 plus on constants are get cancelled. But what is mean by 1 by d dash? 1 by d dash means inverse operator. So we have to integrate with respect to y, not with respect to x. Suppose there is 1 by d operator, then we have to integrate with respect to x, keep y as constant. But we have to integrate with respect to y here and keeping x as constant. But what is the integration for sine of x plus 2y? So minus cos of x plus 2y by 2. That is a sine of ax plus by. Integration is minus cos of ax plus by by b. So like this, just the complete solution is given by adding those two solutions, that is a complementary function and particular integral, which gives the required complete solution. Suppose f of dd dash has a repeated linear factors, so which is repeated odd times, then we have to write the complementary function as same as above, but we have to write 1x, x square and so on, so which is for repeated factors. So it is the only difference between homogeneous and non-homogeneous. But in non-homogeneous or homogeneous, the particular integral concept is the same, ditto. Suppose in case the f of dd dash cannot be factorized into linear factors. In such a case, we have to write cf as like this: summation c e power hx plus ky. What is chk here? So chk are nothing but arbitrary constants or parameters. So summation denotes any number of times may be taken. So finally we have to put d equal to h and d dash equal to k, so that the expression in h and k which is equal to 0. So suppose the problem is like this. Just here we can't factorize this expression into repeated factors or non-repeated factors. In such case we have to take the trial solution as z equal to c into e power hx plus ky. Now we have to find, just we have to replace this value of z and we have to simplify the equation. So we have to take out the exponential function and the expression can be equated to 0, which is f of h comma k equal to 0, which gives the required complete solution. Here pi is not find out because the right hand side of the given equation is 0. Suppose there is a function of xy, then we have to follow the steps. Follow the steps means, as earlier we have discussed in homogeneous partial differential equations. In such case we have to use the particular integral. Particular integral can be used by using these 5 cases. Thank you.